Okay, now moving on to partial fraction of polynomial. So we're gonna check out this example here. We have a simple one. So if you want to do partial fraction, it depends on actually the purpose of this is to break down the fraction that is quite large and turn it into a smaller pieces. I mean, a more simple, simplified forms of fraction, so that you can proceed with next calculation, such as using it in integration, differential, or perhaps you're going to do it for Laplace transform and so on and so on and so on. Okay, so now what we did is that it depends on the denominator, on how many terms of this bracket it has below. So not just the bracket, sometimes they have x or something outside. So if you can able to factor it, and it's going to see how many terms of factors available below, that will determine how many partial smaller parts of this fraction available. Like this one, we have 2, x plus 5, x plus 4, 2. Okay, so if it's 2, then we can split it into a0 with x plus 5, a1 with x plus 4. Now if you have another one extra over here, for example, I have an x over here, x multiplied with this, then we have another one as a2 divided by x. Okay, so in so on and so on, you can add it as many as possible from here. So now we just consider the case of 2. Okay, now in order to solve these cases, what we did is we will multiply this x plus 5 and x plus 4, which is the denominator over here, to the left hand side and to the right hand side, both sides. So you're going to multiply this thing to left hand and right hand side, both sides, and this is what we have. Multiply over here, this one multiply over here, this same thing also multiply over here. Now if you look carefully, this one can cancel off, this one cancel off, so what we have is the final result as equals to 1. And the same here, x plus 5 and 5 plus 5 can cancel off. We only have a0 multiplied with x plus 4, and this one over here, x plus 4 cancel off. We have a1 with x plus 5. Now we already have this equation. We want to find a value for a0 and a1, and of course it is not same as the initial value problem that you found in school. They might give you the x value. Okay, assume that I give you x value equals certain value, and you substitute to get the a0 and also a1. No, for this case you have to assume it yourself for getting the a0 and a1 value. How we do it? Simple. We gonna make one of this term into 0. So for example, like this one, okay, we want to make this x plus 5, right? So we just assume we let x is equals to -5. When you substitute the thing into here, it's gonna turn the one from the back 0 into 0. So the one that available for the front is the one that you have, which is a0 multiplied with -1. So move the thing to the other side, you get your a0 equals to -1. And the same goes for this one. Now we're gonna cancel off this thing by assuming x is equals to -4. So when you put x is equals to -4, the front parts, which is a0, will get 0, and this one you get 1. So you get a1 is equals to 1. So now you have, which is your a0 -1, a1 is equals to 1. So just place it back to the function over here, and you have the thing. Okay, so we look for the second example over here. How many examples left? This one, quite a long one. Okay, now we look at this second example over here. Okay, so what we have is, this is the x, and we have also the same 2 terms below. Okay, so since it's 2 terms, we're gonna place this thing as 2 fraction as well, smaller parts of fraction, which is a0 divided by x plus 1, a1 divided by x minus 4. So 2 fraction as well. Okay, now we do not have to fear that there's x over here and it feels like kind of hard psychologically, but it's not. It's the same. It's the same as what we have from the previous example. So now that you have the setup looking like this. So the next step will be multiplying the denominator, which is x plus 1, x minus 4, to left hand side, right hand side, both sides. Okay, when you multiply this thing to left hand side, right hand side, this is what happened. So you have it, and on the top of this, we multiply on the top of this for a0 and multiply to the top of this for a1. So we can look at anywhere we can cancel since it's a similar term. So this one can cancel off. We only left x over here. This one also, x and 1, x plus 1, x plus 1 cancel. We only have a0 multiplied x minus 4. And the last one, x minus 4, cancel off. We only have a1 with x plus 1 over here. So now we have this equation. Again, we have to do the assumption, since you are not given any x value that can turn this equation around to get the value. So you have to do your own assumption by assuming the value of x that can turn this one of this side or one of this part into 0. So for this situation, we begin with x is equals to -1, placing it into here, and this is what happened. So when you place -1 in this side, and this side, this is the value that we have. So this side over here will become -5. This one becomes 0. So the front will become -1. So -1 divided by -5, it becomes 1 per 5 over here. So this is the first value we have. Second is we place x equals to 4, which will turn a0 section over here becomes 0. So we place 4 in. This one turn into 0. This one turn into 5 again. So just simply substitute the value into here, the x side. So a1 now, by moving this 5 to the other side, we get 4 divided by 5. And there you have it, a0 and a1, the value that you want. Just substitute it into this terms over here, and the 5 can actually bring it down below. Okay, you bring it down below. Now it turns into 1 over 5 multiplied with x plus 1, 4 over 5 multiplied with x minus 4, and this is your partial fraction. Okay, so as simple as that. Okay, some additional example for you. Now let's say if we have a situation where we have the partial fraction of in the terms of 10x divided by x plus 3 and x minus 2. Now as you can see, the below are the same. You have only two terms, so that means later you can split it into a and b over here like this one. Now we look at this, the beginning of the calculation. So we're going to split it into a0 with x plus 3, a1 with x minus 2 over here. Now the next step that we're going to do is to multiply the denominator for this x plus 3, x minus 2, left hand side, right hand side, both. So you multiply this thing in, and when the multiplication happens, it multiplies from the tops over here. So this is what actually you see. You multiply from this side and this side, or a0 and a1 as well. So now we're going to cancel off whatever that we can cancel. So we have as a plus 3 over here, we cancel, x minus 2 we cancel, so we get 10x over this side, and this one we have a0 with x minus 2, this one we have a1 with x plus 3. Okay, now that we have the equation forming in this section, so we're going to use it by substituting some value that can turn this one of the side becomes 0, so that you can get the value for another one. Like for example, okay, we assume that x is equals to 3. Okay, x equals to -3 over here. So substituting x equals to -3 into the equation, we're going to turn this one 10 multiply with -3. This one put -3 in. This one -3. Now this one a1 is automatically gone, becomes 0. The one that left over is -5a0 with -30. So this one we can divide, and you have the result as a0 equals 6. Okay, so you have, there you have it, your a0. Now we're going to go for the second one to get for a1. So a1, if you look at this one. In order to get a1, we have to let this one let it into 0. We're going to turn this into 0 by substituting x equals 2. So this is what they do. We put x equals 2 into the equation. So 10 times 2, and this one will become 2. So we're going to do it according to this equation. So 10 times 2, 2 minus 2, 2 plus 3. Alright, precisely the same. 2 plus 3 over here. Okay, this one becomes 20. This gone, becomes 0. This we have 5. So 20 divided by 5, when you move it to the other side, you get a1 is equals to 4. So there you have it. Your what we call this, a0 equals to 6, a1 equals to 4. So both value already got, and now you can put it over here. You got both of them. You can put it as a0 and a1, and this is your partial differential. This is partial fraction for this function over here, this fraction.